Good afternoon, students. Today, we are going to start the new technique to solve the transformation problem. In the previous lecture, basically, I have discussed about the transportation problem. Here you can see that in the transportation problem, these are the origins and these are the destinations. So from origin to the destinations, we are basically supplying some material and what are the cost needed to transport one unit from one origin to one destination. That is denoted by basically CIJ. If this is your ith origin, this is your jth destination, then CIJ is the cost to transport ith origin to the jth destination. And depending on that, we are able to find out a matrix which is called the cost matrix that already we have discussed. So this will be looks like this. Let us assume that there is three origin, say O1, O2, O3, and four destinations like D1, D2, D3, and D4. So basically C11, this is the cost to transport one unit from origin 1 to the destination 1. Similarly, C23 is the cost needed to transport one unit from origin 2 to the destination 3. So on that way, we are able to find out a cost matrix where some origins are there and some destinations are there. And we have seen in the previous classes that the available amount is A1, say A2, say A3 for the origins, and demands are required for the destinations. Means the destination has some demand that we need some units from from the origins. So this is called say B1, B2, B3 and B4. So B1, B2, B3, B4 are the demand of the destination. A1, A2, A3 are the available amount in the origin. And CIJ basically is the cost to transport one unit from one origin to another destination. So depending on that, we have seen that how we will solve these transportation problems. So previously we have learned two techniques. One is called northwest corner method and matrix minima method to find out the initial basic feasible solution. But before going to solve these type of problems, one thing we must consider, this is very important, that whether this system is balanced or not. Balance means the summation AI must be equals to summation Bj. Means the total available amount and the total demand must be same. So after, if not, in that case, I have discussed in the earlier classes that we have to add one origin, dummy origin, if the available amount is less than the demand amount. If available amount is more than the total demand amount, at that time we have to introduce a dummy destination. Dummy means for only for the solution technique we have to introduce them, but we are not able to. These origin or this destination basically does not exist. So basically there will be no transportation. That is why in the dummy origin or the dummy destinations, the cost will be what? The cost will be zero. And the aim of the transportation problem is nothing but minimize the transportation cost. Our aim is what? Minimize the transportation cost. Okay. So two technique already we have discussed. We are choosing the same problem and we will learn another method which is called the Vogel's approximation method to find out the solution. And later on we will see that among these three methods, Vogel's approximation method gives you more appropriate results, and in that case most of the students always try to go for the Vogel's approximation method. Okay. So Vogel's approximation method, the steps are given basically. So I am directly going to the problem and then we will discuss all these steps. So let us see this problem. So this is a problem where the transportation cost from origin, there is plan P1, P2, P3 and there are warehouses W1, W2, W3. Maybe warehouses is more than plant, maybe the plant is more than the warehouses, that does not matter to us. But these terms basically is nothing but to transport one unit from plant 1 to the warehouse 1, we have to spend ₹7 as the transportation cost. Okay. So ultimately, we have to transport some unit from the origins to the destinations. So these are called basically origin. And these are called the destination. Okay. And these are the transportation cost to transport one unit from one origin to another destination. In this, so this is nothing but the 20 units of some material is available to the plant 1. 28 units is available to the plant 2. 17 units is available in the plant 3. So these are the available amounts in these plants and these are the demands. These are the demands for the warehouse 1, warehouse 2 and warehouse 3 respectively. So from this given problem, first we are seeing that whether this problem is balanced or not. So for that we have to sum these amounts, and if you sum these will be 65. And also if you consider the demands, the sum of the demands is nothing but also 65. So from here we can see that this transportation problem is balanced. So now we can proceed for the initial basic feasible solution, and we are considering the method VAM, means Vogel's approximation method. Okay, so this is the step 1 to check first that whether this transportation problem is balanced or not. Okay. Now what is the VAM technique? So in the northwest corner method, we have considered the northwest corner. In this case, basically, we first considered what is the northwest corner. So we started with this corner point. We have seen that in this corner we can allocate maximum 20 amount. So we are allocating here 20 unit. So rest unit is here 1 unit. In this plant there is no available amount. So this will be deleted. The concept is same, but the allocation technique is different. In the matrix minimum method, we have seen that what is the total among these elements. What is the minimum cost? We have seen that minimum cost is here. So we gone for the allocation first. When we gone for the allocation, we have seen that in this column, demand is 19 unit, available amount is 28 unit. So maximum we can transport here is nothing but the 19 units. 19 units. So on that case, we allocate here 19 units and we basically fulfill the demand of warehouse 3. So this column will be deleted at that time. And in plant 1, the residual amount will be 28 minus 19 means 9 units. So these processes are also same in the case of Vogels, but the allocation technique is slightly different. So let's go for the technique basically. In this problem basically, first we are considering if we are not able to choose the cell with minimum cost, then what will be our second option? And if we choose the second option, then what amount we have to pay more? That is the penalty basically we are paying. So basically, if the plant 1, let us consider P2, P3 is not there. Plant 1, warehouses 1, 2, 3. So plant 1 always wants to transport his unit into the warehouses 2 because there is the transportation cost is 6 minimum. Because 7, 6, 9 minimum is what? 6. So he always try to transport his amount because we always want what? We always want the minimum transportation cost. So he always try to transport in this cell. Let he or she is not able to transport on that cell. Then the next choice will be what? Next choice will be this. So for the next choice, what extra amount he has to pay? So we can see here the extra amount he has to pay is nothing but rupees 1. So this is the penalty he or she is paying when he is not able to transport in his best choice. He goes for the second best choice. That's why the penalty is rupees 1. Similarly, let us assume that P1 is not present, P3 is not present, only P2 is present. So obviously, P2 will try to send all amount with the minimum cost 3. But if he is not able to transport the minimum, not able to transport the amount in this cell, so what will be the next choice? Next choice is this. So in this case, what extra money he has to pay? He has to pay rupees 2 extra. So this is the penalty. Similarly, for P3, the penalty amount is what? 1. So this is with respect to row we have done. Now, let us consider that there is 3 plant and only one warehouse. So obviously, warehouses will try to transport all his amount from P3 because the minimum transportation cost is ₹4. But if warehouses fail to transport from P3, he has to choose P2. And on that time, also he has to pay ₹1 extra. That is the penalty. Similarly, for warehouses 2, first choice will be this or second choice will be this. So penalty is 1. For warehouses 3, first choice is this. If he is not able to transport in this case, what is the second choice? Second choice is this. So the penalty will be on that case 8 minus 3. So this is 5 unit. So among all these penalty we have considered, we have seen that the maximum penalty we have to pay for this case. For this case, we have to pay the maximum penalty. So that is why we are trying to fulfill requirement as well as availability of this column basically. We are trying to fulfill the first service we will give to the warehouses 3. Otherwise, if first choice is not given to warehouses 3, then for each unit we have to pay extra ₹5. So that is why what we are doing here, we are basically choosing this column first for our allocation. In this column, what is the minimum cost? In this column, the minimum cost is ₹3. So this cell will be the first allocation cell. Now the question arises, what amount we have to send here? Obviously, the available amount is 28. Demand is 19. So maximum we can transport is 19. So we transported here 19. When we transport the 19 unit, basically we fulfill all the demand of warehouse. And as 19 unit has been transported from P2, so the available amount here is nothing but 28 minus 19 means 9 unit. And we are going to the next table where you can see that there exists 3 origin, 2 destination. This is your P1, P2, P3. This is your W1, this is your W. And the cost is what? 7, 6, 5, 7, 4, 5. What is the available amount? Here it is 20, here it is 9, here it is 17. This is your demand is 21, this is your 20. So once again, if you add this, it will be equals to this one also. Okay. Now, after reaching here, once again, for each row and each column, we will calculate what is the penalty. So see here, for this cell, the penalty will be 1. For this row, this is penalty is 2. For this one, penalty is rupees 1. With respect to the column, the penalty is here 1. Here it is also 1. So what is the maximum penalty now? The maximum penalty arises in this row. So we first choose this origin, and in this row the minimum cost is 5. So here will be some allocation. What will be the allocation? The allocation will be nothing but the 9 unit, because maximum P2 has available amount 9, W1 has requirement 21 unit, but maximum amount we can transport from P2 to W1 is nothing but 9 unit. So we allocate here. So from here we can see that there will be the allocation of 9 unit here. So after doing the second stage, we can see that we have fulfilled, there is no available amount in P2. So basically this is deleted. This portion will be deleted. And what will be this amount? So 21 minus 9 means this will be 12 unit, and this is as it is, whatever it is, this is 25. So that basically we have shown in the next slide. You can see here that this is 9 unit, and then we gone for the 2 is the maximum penalty and 9 is the allocation here. So after doing this, P2 has been deleted and W3 also has been deleted. So in the new matrix, what we have basically? We have our two origin, say P1 and P3, and destination has what? W1 and W. So the cost, if we write, this is 7, this is 6, this is 4, this is 5. And the available amount will be what? This is 12, this is 25, this is your 20, and this is your. So once again, if you go for the penalty, what you will see? You can see here the penalty is here 1, here also 1, here also 1, but here is. So maximum penalty arise here, so there will be some allocation. And what amount we send here? 12, 17. 12 is the requirement, 17 is the available amount. So basically we are able to send here 12 unit. That I have shown in the next slide. You can see here we have able to send here 12 unit. So when we send 12 unit here, only there is, so basically you have done W3, sorry W1, W3, only W2 is present there. So basically the remaining matrix is in this form. W2, this is your P1, this is your P3. Demand is 25, here it is 20, here it is 5. And the cost is will be 6 and 5. With respect to row, there is no choice of penalty. With respect to column, the penalty is 1. So basically, now is transformed into a matrix where you can see that we have to allocate here 5 unit and we have to allocate, we allocate here 20 unit. And that we have done. So this is the process to allocate the units by the Vogel's approximation method for a transportation problem whose aim is to minimize the transportation cost. So we can see here, this is the number of units allocation. So from origin 1 to destination 4, we have to transport 20 units. Origin 2 to destination 1 will be 9 units. Origin 2 to destination 3 will be 19 units. Origin 3 to destination 1 is 12 units. And origin 3 to destination 2 is 5 units. And you can see that the total available amount in each row has been transported and the demand of each column is also fulfilled. You can see here 9 plus 12 is 21, 20 plus 5 is 25, 90. With respect to row, this is 20. This is 19 plus 9, 28. This is 12 plus 5, 70. Now we have to see that what is the number of allocated cell. So in this case, the number of allocated cell is nothing but the 1, 2, 3, 4, 5. And already we know, we discussed this thing that for the transportation problem, we have to check that the basic feasible solution, for the basic feasible solution, we have to check whether the number of allocated cell must be equals to m plus n minus 1. M plus n minus 1. M is the number of row, m is the number of column, and of the VAM matrix. So here we can see that yes, this is equals to 3 cross 3 matrix. So 3 plus 3 minus 1 means 5. You can see here 5 allocation is there. So basically, this is the initial basic feasible solution. But we will observe a very interesting thing. First, we will calculate that what is the transportation cost needed if you follow the Vogel's approximation method. Let's see. So, as planned 1, warehouses 2, total cost is 120. You can see here, planned 1, warehouses 2, 6 unit. So, basically, multiplying this with this, multiplying this with this, multiplying this with this, and then we are adding to find out the total transportation cost. So basically, total transportation cost means transportation cost TC is equals to 6 into 20 plus 5 into 9 plus 3 into 90 plus 4 into 12 plus 5 into 5. And this transportation cost, you will see that the amount is nothing but 290. This is the total transportation cost if we follow the Vogel's approximation method. So in the previous lecture, we have solved the same problem by the northwest corner method, by the matrix minimum method, and today we have solved by the Vogel's approximation method. I already claimed that the Vogel's approximation method is the best one. To show this, I have chosen the same problem. Let's see what happened here. When we are considering the northwest corner method, whatever the allocation we got, the transportation cost is 462. When we consider the matrix minimum or method or least cost element method, then we got rupees 300 is the minimum transportation cost. But when we consider the VAM method, then we have seen that the minimum transportation cost is nothing but 295. So we have seen that in the most cases, Vogel's approximation method gives you the better result. So for any problem, because in the transportation problem, whatever the cost we got, basically this is depending on the initial basic feasible solution. This is not the optimum one, because the optimality test for the transportation problem is a very important part there. So in next lecture, basically we will upload this thing, the optimality test of the transportation problem. But today we are considering the methods by which we are able to solve this. Okay. So from here, if nothing is mentioned, blindly the student must go for the Vogel's approximation method to get the better result. Okay, am I clear? So now you may face some difficulties when, if I told you that for transporting one unit from plant to warehouse, this is the cost is given, but instead of cost, if this is the profit mentioned, then the scenario will be changed. Because if it is profit matrix is given, then anyone will try to maximize this. But we know that the transportation problem basically gives us the minimum value. So there is a challenge at that time that how we will convert or how we solve the maximizing problem, maximizing transportation problem. So let us. So in this profit is given. So as the profit function is there, everyone try to maximize it. So what we have to do at that time? So if the problem is depending on the profit, be careful, the problem is the maximizing problem. But all the transportation problem or the method we have learned, this is for the minimizing the transportation cost or minimizing the objective function. So if the objective function is maximized, at that time we have to change the problem from maximization to the minimization. So to solve this problem, we convert the problem into minimization. The technique I will mention later. Okay. So and how we convert this? For that, in the payoff matrix, or it is my must the profit matrix. So in the profit matrix, you must find out the largest profit, or you can say that the largest element in the profit matrix, and subtract all the elements from the profit elements. Sorry, maximum elements, and whatever the new matrix you will get, that is nothing but your minimization problem conversion. Means the maximization problem has been converted into the minimization. Now there is two problem or two case may arise. One is what? One is if the problem given is not balanced. If it is balanced, one case. If it is not balanced, another case. So let us go for one problem to execute this one. So in this problem, this is the basically the investment, and there is several methods to investment, and these are the profit. Okay, and basically origin, destination. This is if you transport one unit from here to here, the profit is given. So, and these are the available amounts. These are the demands. So you can see that if we sum up these available amount, the amount will be 210. If you add these amounts also, the sum will be 210. So this is the balance problem. So we can proceed further. Because already I have mentioned that whenever we are going to solve any transportation problem, first you have to check whether it is balanced or not. If balanced, then no problem. If not balanced, then we have to introduce dummy origin or dummy destination. Okay. But in a maximization problem, the thinking is slightly different. You have checked it, it is balanced. So, what is the maximum element in this payoff matrix? So, in this payoff matrix, you can see that 95 is the maximum element. Am I right? I also. So, to convert this maximization problem, we will subtract every element from the maximum element. So, what it will be now at that time? You can see here, if I consider a 4 cross 4 order matrix, one, two, three, four, A, B, C, or here it is written P, Q, R, S, whatever you can write. No problem. So, this amount will be what? 0. This amount will be what? 50. This will be 25. This will be 35. This is 20. This is 30. This is 35. This is 45, and so on. So that I have seen shown here. You can see here 95 is the maximum element. So we subtract and we are getting these elements as the new payoff matrix. And now our the initial problem has been converted into the minimization. After converting this into the minimization problem, the best way will be nothing but the VAM method to apply here to find out the solution. So if we start down this, then you can see we will start with what is the penalty here? 15 unit. What is the penalty here? 20. Next minimum is 30. So this is 10. Minimum is 25. Next minimum is 45. So this is 20. What is minimum element? 35. Next minimum is 55. So penalty is for this case 35, 45. Penalty is 10. 25, 35. Penalty is 10. 15, 30. Penalty is 15. 0 and 20. Penalty is 20. Now, what is very interesting condition situation we are getting here? The maximum penalty arises here, here, here. The question arises which one first we will choose. First thing we will see that if we choose this column, the minimum cost is 0. If we choose this column, this row, the minimum cost is 25. If we choose this, the minimum is 35. So, always mark will go for the row or column with minimum cost. Means our first choice will be this one. Now you may ask that if in all cases इसके लिए भी मिनिमम 0 है, इसके लिए भी मिनिमम 0 है, और this also this is 0. Then what we will do? Then we will think about what is the maximum amount we can transport there. Because our aim is what? Minimizing the transportation cost. So if with minimum cost we are able to transport maximum amount, then the overall cost will be minimized. So carefully we will do this when we are going for the Vogel's approximation method. Don't think about any other things. You must go for the maximum penalty, and in the maximum penalty you must see where is the minimum cost. If minimum cost is also same, then we will see that where we can transport the maximum amount. That row or that column we will choose first, and so on. We will proceed for the Vogel's approximation method to find out the transportation cost. Now, we follow the transportation cost VAM method to find out the solution. We follow the VAM method to find out the solution. Whatever the amount you are able to set in these cells, you basically multiply the cost to find out the profit. You will go to this matrix. Let you got the allocation here, 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 here. 1, 2, 3, 4. Number of allocation कितना होना चाहिए? That must be 4 plus 4, 8 minus 1, 7 allocation will be there. I have done 5. So, more 2 allocation will be there. Let these are the allocations you have done. Following the VAM method. So, the maximum profit will be what? 95 into unit plus 70 into unit plus 60 into the unit and so on. You will add them, that will give you the maximum profit. Okay. So this is for the problem, maximizing problem, which is the balanced one. Now we are considering one case where you can see that the maximizing problem with the problem is not balanced. So in the case of minimization problem, we have gone directly that add dummy origin or dummy destination, whatever it needs depending on the problem, and the corresponding transportation cost will be 0. But here the problem is maximization. So how we will deal with this? Nothing, very easy. First convert this into a minimization. So minimization problem, first convert this, then as it is not balanced, you must go for the adding of dummy origin or dummy destination. And for that, what we will do? Let's see. So what is the maximum element present here? You can see here the maximum element present here is nothing but 44. Am I right? I hope so. So we are subtracting all elements from the maximum element first, and we are getting this matrix 4, 19, 22, 11. Now, as it is not balanced, you can see that the available amount is more than the demand. Means the demand of the destination is less than the available amount in the origin. So, we have to add a new destination, and the transportation cost will be what? 0, 0. And what is the demand of this? Is nothing but 50 unit. So after doing this, you can see that we gone for the, you can see here the dummy destination we have added here, and the cost corresponding to this we have taken at 0, and what is the demand? Is nothing but 50 units. So now it becomes a balanced problem, and you go for the Vaughan's method to find out the solution or the initial basic feasible solution, and then from there, from the original matrix, you will find out the maximum profit of this transportation problem. Okay, so this is the way to approach the solution initial to find the initial basic feasible solution of a transportation problem. If it is minimization problem, then obviously okay. But if this is the maximization problem, we must be careful that we first convert this into the minimization problem by subtracting each element from the maximum element present on that matrix. And later on, to solve the minimization problem, whatever the technique we have followed, we will follow the same technique here also. Okay, so this is all about for today's class. In the next class, we will go for the optimality test of the transportation problem. This is also very interesting part, and it needs more concentration because whatever the solution you will get, it is not necessarily that optimum. Maybe it is optimum, but it may not be also. So on that case, what we will do, that we will discuss in the next class. Thank you. Thank you.